Hey everyone, now that you've conquered differentiation, good for you on that, it's time to move on to the opposite of differentiation, integration. So what do I mean by the opposite of differentiation? Well, simply, let's just use a very basic example. So we've learned that if I have a function y equals to fx, the derivative would be f prime x, right? So the opposite being that in differentiation, we have the derivative from the original function. In integration, we will have the original function from the derivative. And this is how we represent it. So let's say I have fx again. I obtain fx by integrating the derivative with respect to x. As you can tell, there's many similarities, right, between integration and differentiation. One of them is actually seen right here, the dx. In differentiation, you're differentiating with respect to whatever variable you want, right? And for in this case, we are differentiating with respect to x, therefore we write a dx. In integration, if we want to integrate with respect to x, we also write a dx. The only thing that's new here is the integral sign that looks like an S shape. One way that you can remember, kind of a lame way actually as well, integration as in, right? So sine. Yeah, I'm sorry. Moving on. There's actually another way, there's another term for this original function. It's what we call by the antiderivative. So antiderivative, right? So anti being opposite, right? So instead of looking at it as an integral of a derivative, we look at it as a integral of any function. So let's say I integrate fx, right? The antiderivative would be capital letter Fx. So, f, capital letter F, being the kind of like the parent letter to the small f, and that's why we give it as the antiderivative. And this is only mainly for the H2 math syllabus and for the H2 math students. It's not really a term that you encounter a lot in O levels or in H1 math, but it's also a good to know thing. But mainly just stick to this idea when it comes to dealing with applications or actually just normal integration. Nonetheless, all right, this is just a quick introduction to differentiation, and you can actually stop the video right now. But I'm actually going to move on to how integration actually came about. And to do that, I'm going to introduce to you guys the Riemann integral. So the Riemann integral works like this. I have a graph, okay? So let me draw my favorite curve. So let's say y equals to fx. Just like in differentiation, we're going to consider 2 points, right? Let's say point A and point B. Now, in point A to point B, how are we to find the area underneath the graph? So one way to do it is, well, let's take a rectangle. Okay, like this. Clearly, this is not a great estimate, right? Because there's this top area right here that is not counted in. All right, then, what if you add a line in between? Okay, and now what would happen? Same thing, right? But this time around, it's smaller, correct? It's getting smaller. Okay, now what if we reduce the width between each rectangle? Okay, like this. And then you get this, and then you get this. Okay, doesn't help, right? But what do you notice on the left side? The left side, the rectangle is kind of like perfect, right? It's kind of like perfect between the graph and the axis. So why not we just continue? We're not just limited to 2 rectangles. Why don't we just keep adding one more and more and more and all the way till you get almost infinite numbers of rectangles ending at x equals to b. And if you take the sum of these rectangles, it would eventually give us the area underneath the graph from point A to point B. And this is the whole core idea of integration. And in layman's terms, and to put it loosely, this is also the reason why integration is the opposite of differentiation. Because in differentiation, we're looking at the gradient, right, between 2 points. So when we talk about gradient, we are involving a difference, right? In integration, or in this case, the Riemann integration, we are looking at the summation of rectangles formed between 2 points. And obviously, in differentiation, we're considering the difference to be very small when x is very small. In integration, we're also considering when the width is also very small. And therefore, minus is the opposite of plus, and we end up with differentiation being the opposite of integration and vice versa. So yeah, this is the introduction to difference. What a great ending, whatever. I'm just going to keep this ending. This is the introduction to integration.